All right, this is your Unit 6 review. Don't forget that there is also the Activities 36-37 review that has information from Unit 6 in it as well. So like the summations and stuff from earlier in the chapter, you may also want to check out that video. Okay, so we're just going to pick and choose a few things here. And as I look at this, first thing I want to go over is the MAD value, mean absolute deviation. Remember that when we are talking about finding a MAD score, it's like reading the word backwards. Because what we're going to do is we're going to find the deviation first. Then we're going to take the absolute value to make it positive, and then we're going to calculate the mean of that. So mean absolute deviation means how far is each individual value on average from the mean. So in number 1, you were supposed to calculate the mean and standard deviation. Obviously, you should be getting those directly from your calculator. So in number 1, we found that the mean was 8.2. So that's the value we have to use to find our MAD. So I take every individual score here and I find out how far it is away from this mean. So I'm going to use the absolute values. So I take value, which is 7, minus the mean. And then I'm going to do the same thing for all the values and I'm going to add them together. So 8 minus 8.2. So I did these two. Now I've got another 7. So 7 minus 8.2 again. Then a 10. 10 minus 8.2. And finally 9 minus 8.2. So 7 minus 8.2, because of the absolute values, these are all going to be positive, but I get 1.2, 0.2, 1.2, 1.8, and 0.8. So you add all 5 of those together, and you should get 5.2. And then we've done the deviations, we've done the absolute, now we're finding the mean. So add them all up and divide by how many there were, which in this case is 5. So 5.2 divided by 5 is how I got my MAD value of 1.04. Remember that mean absolute deviation as well as standard deviation measure the spread. They're telling you how far data values are on average from the mean. So if our mean is 8.2, it's saying that on average the values are within 1 on both sides of that. So that's what that's saying. All right. I'm going to review some of the calculator stuff here real quick. So we've got our information about Ryan and Brent and their Burger King French fries. So the 5-number summary, this all comes from the calculator. So you have to enter this data into your calculator. So to enter data, we go to Stat Choice 1. So I'm going to use list 1 and I'm just going to enter all of these values. Remember how important it is to double and triple check when you're entering or when you're done entering, because if you enter a number just 1 digit off, then now suddenly all of your answers in this section are wrong. So really, really important to make sure that you check your work there. So 173, 171, let's see, 168, 167, and then I had 2 170s. So the first thing I always check after I enter it is I check, this says L115, which means that would be the 15th entry. It does say here they ordered 14 large fries, so I should have 14 pieces of data, and then I just go through backwards and check it. 2 170s, 167, 168, 171, 173, 168, 166, 152, 166 again, and 159, 160, 163, 165. So I've double checked it. I know that I've got my data in there correctly. So once I've done that, to get my 5 numbers, I go to Stat, scroll right to Calculate, and then I'm going to choose choice 1. So enter or 1. Tell it what list you're using, and if you have an older calculator, you get the home screen. Just name the list that you want it to calculate on. On the old calculator, after you name the list, just press enter. Here we scroll down to calculate and press enter. Remember that this gives us the mean also. It didn't ask for it here, but that would be 165.57. Standard deviation is your SX, 5.57. Again, it didn't ask for it here, but just knowing that that's in the same screen. My 5-number summary is at the bottom, so I have to scroll min Q1, median Q3, max, and we just copy those values down. So 152, 163, the median was 166.5, Q3 was 170, and the maximum was 173. So remember, on a regular box plot, all you do is make the min and the max your dots that make the whiskers. Q1, median, Q3 become your box. If it asks for a modified box plot, which it does in number 6. Remember, that means you have to exclude outliers. So we're going to look at outliers in number 5. The formulas for outliers are on the upper Q3 plus 1.5 times the IQR. For the lower boundary, it's Q1 minus 1.5 times the IQR. So I have my Q1 and Q3. Remember that that's how I find IQR to begin with. I take Q3 and I subtract Q1. So in this case, 170 minus 163. So my IQR is 7. So upper boundary is going to be Q3, which is 170, plus 1.5 times 7. So when I do that, I get 180.5. Lower boundaries start with Q1, 163 minus 1.5 times the IQR. And that's going to give me 152.5. So now, outliers, I just have to look at my list and see if any numbers are above 180.5 or below 152.5. So as I look at them, 152 is an outlier for sure. Got that one. Keep looking. Lower than 152, higher than 180.5. That's it. So there's only one outlier. When I do the modified box plot, almost all of it looks the same, except this minimum. So I'm going to plot my Q3, median, Q1, and max just like I did up here. So 163, so 162.5 would be right in the middle, so it's just to the right of that. 166.5, about right here. 170, so that makes my box. My max is 173, so right here, connect it. Now it says mark any outliers with an asterisk, so my outlier is 152. It's down here. It gets an asterisk. Do not connect the whisker. On a modified box plot, you choose the lowest value that is not an outlier. So when I look here, 159. Yep, 159 is the lowest value that's not an outlier. So it makes my whiskers, and that's my modified box plot. All right, next one I want to do is number 8. So I already went through on the calculator how to find your 5-number summary, which also gives you your mean and standard deviation up here. So the answers that I gave you in class, these ones, I just got that same way. Number 8, determine the interval that represents one standard deviation on either side of the mean. That just means one standard deviation below the mean and one standard deviation above the mean. So the mean in this problem was 26.75 and the standard deviation was 5.651. So I just subtract the standard deviation to get my low boundary, which would be 21.099. And then the upper boundary is going to be the mean plus the standard deviation, because that gives you one standard deviation on either side. And when I add those, I get 32.401. I want to make sure you know the difference between number 9 and number 10. Number 9 asks you to calculate the portion of data that fall in your interval. That means to actually look and count. So it has to be between 21.099, so since these are all whole numbers starting at 22, up through and including 32.401, which means it would include 32. So between 22 and 32 would be this guy, this guy, this guy, this guy, and this guy. So of the 8, 5 of them fell. So the proportion would be 5 out of 8. If you wrote it as a decimal, I think it's 0.625, that would be fine also. But it says proportion there. Now, the difference between that and 10 is that in 10, they've told us it's normally distributed. Nowhere in this earlier part of the problem did they use those words. In order to use the calculator for proportions or percentages, you have to know that it's normally distributed. So because we didn't know that in 9, that's why that one should be done by hand. If it had said in the directions that it would be normally distributed, then we could actually do 9 the same way we're going to do 10, which is to use our normal CDF feature. So again, it's on your calculator handout sheet, but in order to do normal CDF, we press second and then vars because we're looking at distributions, which is in blue above that. We're going to choose number 2, and then we have to give it 4 values: lower boundary, upper boundary, mean, and standard deviation. So the question asks on number 10, what would the probability be that a randomly selected racer will finish in 30 minutes or less? So that means between 0 minutes, which would obviously technically not be possible, and upper boundary of 30 minutes. So finishing between 0 and 30 minutes would be 30 minutes or less. Then I type in the mean. That symbol, remember, is another symbol for the mean. Which I had found in number 7, and we wrote down right here, 26.75. So 26.75 is our mean, and my standard deviation that I had calculated is 5.651. So then I go down to paste. It types it in for me. If you have an older calculator, remember, you don't get the prompt screen. You just have to know how to enter these 4 things: lower boundary, comma, upper boundary, comma, mean, comma, standard deviation, close the parentheses. Once you have that, press enter, and it's going to spit out the probability for you, so 0.717 approximately. Please remember that if it says probability, the answer should be a decimal. We only list a percent if it says percent or if it says proportion, but if it says probability, the answer should be a decimal. All right. Next thing that I want to look at on the next page here is how to find the equation for the best fit line as well as the correlation coefficient R. Remember that in order to get R to show up, you have to have your diagnostics turned on. So there are 2 ways that you would possibly have to do this, and we already did it in class, so unless you've had to reset your memory, take your batteries out, or you've changed it, it should still be on there. But if not, Sometimes you can look in mode if you have a newer calculator. If you go down here where it says Stat Diagnostics and you choose On. Now, the older calculators don't even have that in the mode screen. So if you have it, make sure Stat Diagnostics are turned on. If you don't have that, then what you will have to do instead is press second and then 0, because that takes you to the catalog, which is everything that the calculator does listed in alphabetical order. And then we have to go down to D for diagnostics. You can either scroll or you can press alpha D. Actually, that didn't work. I thought that it would. So I guess I'm going to have to scroll all the way down to D. So going through, because we need to find where it says diagnostics. You can see all the lovely things that the calculator can do for you. Oh, we're to C, almost. And it's scrolling. All right, there are the diagnostics, and of course now it's scrolling too much. Stop. But you get the point. If I could get it to stop scrolling the wrong way. You go to diagnostics on and you press enter. Okay, I need this to stop. Quit. All right, it will not stop. So I'm going to pause the video, try to get this to stop, and then come back. All right, that was slightly crazy, but it's better now. All right, so in order to do the line of best fit and get the correlation coefficient, you have to enter data into two lists because you have X and Y data. This is bivariate data. So if you go to Stat, and we're going to choose choice 4 to clear the list. So I'm going to clear list 1 where I had put the data earlier. That's done. So now Stat choice 1 for edit, and I've got list 1 and list 2 where I'm going to enter the height data and the speed data. So 100, 196, 70, 50, 192, 152, 100, 131, and 210 for my X's. So then go over to list 2 and enter the corresponding speed data. So our miles per hour here. All right, and as always, make sure that you double check your data. Make sure it's lined up correctly. Remember, on bivariate data, the order matters. So if you skip an X value or a Y value, you'll have to go back and re-enter them from that point because the 192 has to be across from the 66, so on and so forth. All right, so to get a best fit line in the correlation coefficient, once your diagnostics are turned on, you're going to go to Stat again and Calc, and we choose choice 4 for linear regression. We tell it what lists we want. If you have the older calculator, remember you put commas between. Here we just put it in the prompt screen, so L1 and L2. Then we go down to store regression equation, and we do vars, yvars, choice 1 for function, and choose where to paste it. So in the old calculator, you should have L1, comma, L2, comma, Y1. Then press enter or calculate, and it spits out our information for us. So I can see that my best fit line, the A value is the slope, so y equals 0.2143x, and then my B value is my y-intercept, 28.1741. Again, because my diagnostics were turned on, I can see my R value, and R is 0.783, which this indicates a moderate positive correlation. Remember, strong should be very close to 0.9. So this is a moderate correlation, which you could also see in the scatter plot that you did. Define the slope. Remember, these are like a script. You always say for each additional, and then whatever X stands for. In this case, X stands for height in feet. So each additional foot of height, then we say the, whatever Y is standing for, speed, in this case, of the coaster. And then you say increases or decreases based on whether it's positive or negative. This is positive, so increases by whatever the number of the slope is, so 0.2143, and then the label for speed in this case is miles per hour. All right, now in 14 and 15, we have to use our best fit line. That's why that vars, y-vars step is so important, because that pastes your equation into your y equals screen for you. We're also going to need to adjust our window to make sure it's appropriate. My x's are the height value, so I'm going to want that to go from 0, even though my lowest one is like 50. My highest value is 210, so maybe go up to 250, counting by 50s maybe. My y's, in this case, the speeds, I'm going to go from 0, which is obviously well below what I need. The highest speed that I have in that table is 83, so I'm going to go up maybe to 100, and that should be good. Because then if I graph it, I can see my line. The reason why that's important is because in order to find the residuals, you have to have the predicted value. Now you can do that by hand if you want, but when you go to do a residual plot, that's going to take an awful lot of time. So the best fit line here, if we do it by hand, to predict the max speed for a coaster with a height of 70, so using the best fit line would just be to do this. Plug 70 in for X. Now this is a rounded value that I'm doing by hand, so that's going to be a little bit different than what I'm going to get using the calculator. Using the calculator, I wowould do second trace, choice 1 for value, and I would type in 70. And it spits it out for me, 43.17 approximately. Our speeds, we have all whole numbers, so it would be fine to use the whole numbers here if we wanted. I would probably round to at least the hundredths place. But remember, the residual is the difference. It's the actual value, actual minus predicted. So the actual value at 70 feet, I can see in here, was 55. So I do 55 minus 43 point, and maybe we can just make it 0.2 to make it easier. But that gives you your residual, which is 11.8. To do a residual plot, you have to do actual minus predicted for all of these values, which means what I did is I just made a column for predicted and filled it all in there. So I went in my graphing calculator and I just kept pressing in values. So I pressed in 100 because I'm already in second trace value. So if I type 100 and press enter, it's going to give me the predicted value. So 49.6. And I wrote that down. 49.6. Then I typed in 196. Pressed enter. And it gives me 70.2. This is so important because that's how we get our residuals. The actual, which is 55, minus the predicted, which is 49.6, gives me my first residual. Then I subtract here to get my second residual. So the residual plot that I had when we went over this review in class had all of those values plotted. All right. Marginal data, remember marginal just means the total on the row or the column. So the row totals are already there. So here you're just adding. So 13, 17, 30, your marginal totals are done. So in order to calculate percentages, you have to look at what they're asking for. So this is asking about Kellogg cereals only. What percent are classified as below average? So there are 10 total Kellogg cereals listed. Below average was 4 of them. So 4 out of 10, which gives us 40%. This says how many, not percent. So above average in the study means total, all of the cereals. So above average, that column total was 17. Segmented bar graph, you have to make sure that you fill in, which one is which, your little legend or key over here. Make sure also that your bars are in the same order. If you do above average first for General Mills, you need to do above average first for Kellogg's. And it doesn't matter which one you do first, but it needs to stay consistent. Remember that evidence of association is if the bars show significant difference between each other. All right, again, reminder that this video is not meant to be comprehensive of everything in this unit. You can go back to the activities 36, 37 review if you feel like you need some more reminders of some of the other things that we've done. Make sure you look back through your notes, your homework, and make sure you know your definitions and how to use your calculator. Happy studying!